secant and cosecant graphs. Suppose you were asked to graph y is equal to cosecant of x minus pi over 2. First, you should graph the reciprocal. Reciprocal of cosecant is sine. The first we're going to graph this, a positive sine graph. Since this is not the graph that we really want, I'm just going to dash it. Now, the start is going to be when the angle is 0. Again, if you subtract two things and you get 0, it's because they're equal. Okay, so we now know where it starts. Where does it finish? It finishes when the angle is 2 pi. But I'm going to write it down as 4 pi over 2. Why? So when I add the pi over 2, I have common denominators. Just remember that that is 2 pi. This cancels out by design, and we get 5 pi over 2. Okay, 5 pi over 2. Now, and the highest value is 1. So now, in between 1 and 5 is 3. 3 pi over 2. In between 1 and 3 is 2. 2 pi over 2. So a half pi, 1 pi, 1.5 pi, 2 pi, and then 2.5 pi. That is, this distance here is, let me just center it a little bit better. It really should be right there, 1 pi. Okay. So, what we have is this distance between half pi and pi is half pi. And that's exactly how far away the origin is going to be from that point. That is, there's the origin. The high is 1. The low is -1. Label it the y-axis. Now, how do you go from this graph to the graph that we wanted? After all, we want to graph this, and I went and I graphed that. Well, wherever the graph crosses the y-axis, the x-axis, draw a vertical asymptote. Step 1. Wherever the sine, this is true for secants and cosecant graphs. So first you draw the reciprocal. Wherever the reciprocal, whether it's sine or cosine, equals 0, you draw a vertical asymptote. And then you go from the high point and you go like this, get closer and closer to those vertical asymptotes. You go to this low point and you go like this, getting closer and closer to the vertical asymptote. What is in green is one period of this secant graph. Let us try some more. Suppose you were asked to graph y is equal to 2 times the cosecant of x plus 3 pi. Okay, so first we graph y equals 2. The reciprocal is cosecant is sine. We graph this. Okay. So, there it is. There's the x-axis. Where does it start? It starts when the angle is 0. Bring that over. You get that it starts at negative 3 pi. Okay. It starts where it starts, folks. Where does it finish? It finishes when the angle is 2 pi. Well, if you have 3 pi, you better take away a pi to get 2 pi. That's going to be negative pi. If you don't believe it, take away 3 pi from both sides. The left side is just x. 2 minus 3 is negative 1 pi. Okay, so it finishes at negative pi, negative 1 pi, negative 2 pi, negative 3 pi. In between negative 1 and negative 2 is negative 1.5 pi. Between negative 2 and negative 3 is negative 2.5 pi. Okay. And this length is pi. So, and since this is negative pi right here, I have to go pi to the left. Make that to the right to get to the y-axis, which is pretty much right there. So x-axis, y-axis, the highest value is the absolute value of 2. The lowest value is negative the absolute value of 2. Now we find where it crosses the x-axis and we draw our vertical asymptotes. And then we go like this, and we go like this, and everything in blue is the graph that, if you like, was very, very helpful, but if you like, you could remove that sine graph. And there it is. If you were asked to graph y is equal to negative 3 secant of x plus pi, you graph y is equal to negative 3. The reciprocal is cosine of x plus pi. Okay, it is a negative cosine graph. So I draw a negative cosine graph. And we find the start. That's when the angle is 0. So x must be negative pi. Okay, negative pi. And it finishes when the angle is 2 pi. Well, you should know that pi plus pi gives you 2 pi. So x is pi, which is great. I love having the start and the finish just being different by a sign. That means that the y-axis is right in the middle. And the highest point is the absolute value of 3, and the lowest value is negative. The absolute value is 3. And like always, we find where the graph equals 0, and we draw our vertical asymptotes. This high point goes like this. This low point goes like that. Of course, if we continued this graph, there would have been another vertical asymptote here, and this green piece would have come down. But we're only drawing one period. Also, let me comment about this and all the graphs we've done so far. Here, the green part. This is just one period. It keeps repeating. First, we repeat this piece, which is right here. And then we repeat the piece in the middle, which is right here. And we just keep repeating this. You're going to then have this, which is this piece right here. Just keeps repeating. I just repeated it to the right. It also repeats to the left. Now, want to see something. Guess we haven't done this. Our amplitude, phase shift, and period. Well, these graphs go up forever. They even go down forever. So we never talk about the amplitude. The phase shift is where it starts. The period is the finish minus the start. The period is going to be 5 pi over 2, that's the finish, minus 1 pi over 2. Just think about 5 inches minus 1 inch. It's 4, and then the units. The units are pi over 2's. So you have 5 minus 1, which is 4, pi over 2's. Oh, I could simplify that. So the period is 2 pi. In the last problem, okay, so I guess this was 2 different problems. There is no amplitude. You have the phase shift, you have the phase shift and you have the period. The phase shift is where it starts, negative 3 pi. The period is the finish minus the start, and that's 2 pi. In this problem, the phase shift, it's where it starts. X equals where one period starts. And the period is the finish minus the start, which is 2 pi. So the period is 2 pi. So let's up the level of difficulty. What if we had y is equal to 2 secant of x minus pi plus 3? X minus pi plus 3. So I guess you can learn how to graph these, but independently of the sine and cosine graphs. But it's so much easier just to graph the reciprocal and then convert that reciprocal into, in this case, the secant graph. So we want to graph this. And since we have this plus 3, we have to do the high, the medium, and the low. Usually, the high is the absolute value of 2. The low is negative, the absolute value of 2. The middle is 0. But somebody went and added 3 to all y values. So the high is 5 now. The middle is 3, and the low is 1. So let's just make believe temporarily that this here is the y-axis. And I want to bring that 5 up a little bit. Okay, so our graph is going to be in between here, where that middle line is like the center. So we're supposed to draw a positive cosine graph. Okay. Perfect. Probably one of my nicest cosine graphs. Okay. So now, and it's unfortunate because I didn't mean to really draw it, because that's not the graph that we want. So I am dashing it. Okay. Now that we did this, let us find the start and the finish. The start is when the angle is 0. That's when x is pi. By the way, if the y value is 1 here, then looks to me like this will be the x-axis. And it starts at pi, right underneath. Okay. Now, where does the graph finish? It finishes when the angle is 2 pi. Well, you better have 3 pi's, so when somebody takes away one of your pi's, you'll have 2 pi's left over. That is, it finishes at 3 pi. Okay, and dead center will be 2 pi. Now, it seems like we lucked out. If this is pi, it's a little bit short, but let's call that distance pi, and that would be 0 then, where the y-axis goes. Okay. So now, we need to keep in mind the middle. This is the middle. That's where it quote equals 0. Okay, if we didn't add the 3, that is, we have the the vertical asymptotes over here and here. And over here we go down like this, and over here we go like that, and we go like that. And what's in purple is one period of this graph. Don't go to see where this graph, which I'm going to put in solid yellow, where it equals 0. Okay, because it never equals 0. It never crossed the x-axis. But it kind of equals 0 here. Okay, now what are those angles? What's in between 1 and 2? 1.5. 3 halves. What's this? And you can add 2 and 3. You get 5 divided by 2 to find the middle. Pi. Okay, if you plug in 3 pi over 2, this, for x, this graph would be undefined. I apologize. This graph would be undefined. We can try that. What is y equal when x is 3 pi over 2? 3 pi over 2, that's 1.5 pi, minus pi plus 3. Well, 1.5 pi minus pi is half a pi. Well, what is the cosine of pi over 2? That is, what is the cosine of 90 degrees? Well, 0 degrees, 90, 180, 270, 360. It's 0. Oh, so this is the reciprocal. Oh my, you can't take the reciprocal of 0. That's where the vertical asymptote occurs. Same thing for the other value. Looks to me like 5 pi over 2. most importantly, there is the graph. Now, let us do one more like this. Y is equal to -2 secant of x minus pi plus 3. The only difference is it's negative now. So y is equal to 2, -2. The reciprocal of secant is cosine. And I shouldn't say y equals, because y is equal to this. You know, maybe we can say, call it y prime, but let's call it y anyways. So we want to graph this. So we are ignoring this to the very end. We want to graph this. It has this plus or minus, so we play the high, middle, low game. The high is usually the absolute value of that number. The low is negative the absolute value of that number, and zero's in the middle. But now somebody went and added 3. By the way, these are y values. The high is y equals 2. Y equals 0 for the middle. Y equals -2. But like I said, somebody went and added 3 to every y value. So 1, 3, 5 looks to me like that would be the origin. And let me just have this line. Now what we want to do is graph this cosecant graph. Okay, cosine graph. And we know it's in between 1 and 5. And it is a negative cosine graph. So it starts here or here. You decide where it starts. It goes like that. Okay. So where does it start? It starts when the angle is 0. Well, pi minus pi is 0. So it starts at pi. And it finishes when the angle is 2 pi. Well, if you're going to take away pi and have 2 pi's left, you better start with 3 pi. So this here is 3 pi. The middle is going to be 2 pi. Between 1 and 2 is 3 over 2 pi. Add the 2 and the 3. Divide by 2 pi. Okay. And what we have, for example, is this distance is 1 pi. 1, 3, and 5. So I should go to the left of pi. Approximately pi units. And this is 1 and 3 and 5. Okay. Labeled everything, ready to go now. The zeros are here and here. Let me just lower this a little bit. Okay, up here, go like that. Over here, go like this. Over here, go like that. Whatever you see in green, that is this graph right there. And that completes this section on graphing secant and cosecant graphs.